I had a student reach out to me with questions about 12.1, in particular, the ones that involve graphs that are from 6 through 10. So we'll look at a few of them together. The most important thing is to understand the question that's being asked and what the graph displays. And so we have this graph that displays receipts versus outlays. And the question is, in what years did receipts appear to climb faster than outlays? So here the outlays are increasing at a pretty steady rate. Here the receipts are decreasing. Here they're increasing. And they want to know, when does that increase down here appear to be steeper than the increase in the red? Where does the increase in the blue appear to be steeper? It does appear to be steeper here in the 2019 area. So reading the question, I might go down and look at the answers and say, well, I'm going to grab the 2019 because that's way steeper than that. And then I'll go to another place where I feel like it's steeper. Maybe I'll just look at these. 2015. If I go to 2015, yeah, that does look steeper than that. So maybe I would choose this one just based on those two observations and having them both be there. And it's going to say, hey, you did a great job. This next one, as you're doing a graph problem, you want to make sure of two things: that you understand what's being asked and that you understand the graph. So let's understand the graph first. The graph is giving me years, obviously 2016 to 2021, and what it's reflecting is the percent change from the previous year. So in 2016, the percent change in the previous year was above 1.6%, but not quite 2%. 2017, it was above 3.6%, but not up to 4%. So let's read the graph. The bar graph shows the trends in the consumer price index over the period 2016 to 2021. Over this 6-year period, about what was the greatest change in the consumer price index and when did it occur? Well, this represents the change in consumer price index. So this is obviously this big bar at the end of 2021 is obviously the biggest change. And so we'll go put in 2021 as the year. And now we need to determine what percentage that is. Well, that's right on the 7.2 line. That's kind of nice. And so we'll answer 7.2% and check that answer. And we'll say, hey, you did a good job. Now, was it hard math? No, it was just understanding the information that was being conveyed as well as the ask. So as you go to this next one, same thing. We could look at what's happening here in this graph first. It looks like this is money that they have, and this is an annual rate of return. So a 6% return, 7% return, 8% return. And this is showing when the value of the account at her particular age or his particular age, right? So at age 60, it looks like she starts out with 400,000. If the rate of return on average was 8%, it would climb to 800,000, but then she's older, right? So she needs to draw on it, and so it drops off. And it looks like it runs out here when she's like 86. If it was only a 7% return, that 400,000 would run out before she was 80. And if it was 6% return, just after she was 75. So let's read this. Claire wishes to retire at age 60 and is studying the comparison line graph to the right, which shows, under certain assumptions, how the net worth of her retirement savings, initially 400,000 like we saw, at age 60 like we saw, will change as she gets older. And as she withdraws living expenses from savings, assume Claire can maintain an average annual return of 7%. How old will she be when her money runs out? Okay, well 7% is this middle one, right? This orange one. How old does it look like she's going to be when that money runs out, when the value of the money gets to zero? Here the value of the money is 400,000, maybe climbs to 500,000 there, but then starts to fall off 200,000, 100,000, zero. Well, that looks like she's about 78, 79. They have 79 for me to check, and so I'll check that and they'll say, nice work. Cool. So here's the danger. We could look at this problem and assume they're asking the same question. I could read a little bit of information and says, hey, 6%, cool, I know what I'm doing. 6% is this line, that's age 76. I'm going to type that in, and it's going to tell me, no, that's wrong. Well, the reason why it's wrong is I've forgotten one aspect of that. I feel really good that I understand this graph, right? Hey, her money's going to run out when it's 76, right? If this is blue 6%. So why did I miss it? Okay. The question isn't what her age is. If I go back a question, it was how old will she be when her money runs out? This is a new question. How much longer can she expect her money to last? I'm like, oh, well, she's 60 now, and that's 76. That's just 16 more years. So I think it's 16, but I'll miss that as well because I need to read the question. Suppose Claire has $400 at age 60, retires at 60, reaches age 73 in good health, and that average annual return has proved to be 8%. So she's 73 right now. How many more years will her money last? I'm looking at that blue line at 76 years of age. 76 is 3 years beyond 73. And they're making sure that I'm a good analyzer. So you want to read that information. What options might she have in order to extend that time? She shouldn't spend her money more lavishly. She can opt for retirement savings schemes at a lower percentage of return. That doesn't make any sense. She can cut down on her expenses. Okay. So they're just trying to help us be a better steward of money. And so forth and so on. I mean, we could take a look at this, but it really is the same type of problem. Reading the graph, understanding it, and then answering the questions as appropriate. Sorry for my voice there. Thank you for watching this video.